Hello all. Katie and I are going to present our talk on trusted or busted identity proofing. So let's see first, what is identity proofing? It is used to establish the uniqueness and validity of an individual's identity to facilitate the provision of an entitlement or a service. In our case, we'll be talking about document verification such as driver's license or passport. Our talk will highlight the results of our evaluation of third-party providers such as Onfido or Jumio, which are currently used in finance, retail, and travel industries. Our talk on busted identity proofing services is especially relevant amid the current COVID-19 pandemic, which has forced many organizations to shift to a remote workforce. As a result, automated identity verification solutions have experienced quick and widespread acceptance. They also introduce convenience and efficiency. So let's go over the workflow. It all starts with the document capture where you digitally scan an ID. Then the document is classified into various types and subtypes. The service then reads and extracts the relevant personally identifiable information and validates the format. Finally, the liveness or the selfie test is done as a proof of ownership, and based on that, the service marks the entry as a pass or a fail. So let's see what happens behind the scenes. Identity proofing solutions rely on state-of-the-art methodologies. They use AI classifiers to classify a document based on the country, the issuing authority. Then they use OCR and computer vision to extract and read the data from an ID. Finally, the solution utilizes deep learning models that inarguably spot characteristics of fraudulent IDs, such as unique fonts, pictures, and built-in securities like barcodes or ghost images, thereby detecting any kind of digital fraud. With this introduction, now Katie will go over the test cases.
As Aakanksha described, many of these services have advanced techniques for processing IDs, which allows them to easily detect many digital modifications that may be applied to submitted documents. However, how easily can these techniques identify physical modifications? With physical modifications, there are no alterations being made to the original images, therefore copied bytes and font mismatches are no longer present. As a result, we were able to circumvent these processes and achieve impersonation through a variety of methods. The first test case that displays this weakness is the use of a modified photo. We tested with both a Washington license as well as an Indian passport, and both were accepted as valid IDs. As you can see, a face was cut out from a different photo and pasted onto someone else's ID. It would be very clear to the human eye that these IDs were modified, but to a machine, it appears to be an acceptable photo. There is also no photo comparison being done between the actual photo and the ghost images, which is a security feature Aakanksha mentioned. Next test case includes a physically modified name. This ID was scanned and then a letter was cut out from the scanned version and pasted onto the real ID. The ID was accepted by the system and the edited name was successfully read from the ID. Our last test case showcases the weaknesses in the mentioned service's abilities to verify all necessary security features on IDs. This test case specifically involves the barcode found on a driver's license. If using a driver's license with one of the proofing services, you will be required to upload the front and back of your ID, and data will be extracted from both sides and compared to make sure that they match. However, what happens if the barcode can't be read? We generated a barcode in an incorrect format that cannot be read properly. It was then printed out and pasted onto a valid driver's license, and it was accepted by the target system. This shows that if we successfully change any data on the front to impersonate someone, then we don't need to also generate a valid barcode to match the changed data. In conclusion, there are two approaches that we've seen for identity proofing, manual and automated. With a manual approach, we can identify most physical modifications that may be applied to an ID. You are also, more often than not, relying on the actual physical ID as opposed to relying on a photo of the ID. However, manual proofing may not be as convenient, and a decent amount of experience is required to securely perform the proofing. With automated proofing, it's definitely faster and more convenient in most cases, but as we've shown, it falls short in detecting physical modifications. There is also a need for a large as well as evolving dataset to account for the vast amount of IDs and how often their format changes. As a result, our consensus is that both approaches are needed to provide the most accurate proofing.